The California Academy of Science is an awe-inspiring structure. This wonderful museum is the greenest museum in the world, and that is because of the impressive sustainable strategies and methods that the architect and engineers ideate to create these wonders of today. This sustainable museum is located in San Francisco, California, surrounded by the Golden Gate Park. The brilliant design of the Academy was from Enzo Pirano, who wanted to lift up a piece of the park and put a building underneath, and with collaborations of Arup, Webcore Builders Inc., Rana Creek Ranch, Swap Group, and others. This green museum contains an aquarium, a planetarium, a natural history museum, a research and with educational facilities. Features a green roof, a 2.5-acre expanse of native California plants and wildflowers that create a new link in the ecological corridor for wildlife and numerous sustainable features.
The California Academy of Science optimized site potential. The California Academy of Science was founded in 1853 and it's the largest cultural institution in San Francisco. It was built in Golden Gate Park to replace the previous building that was damaged in the 1989 earthquake. Unlike the rest of the buildings around, this one, instead of landing on the city, covers itself with a green roof that allows the building to represent an important green point in the city. This museum not only become an advantage to the green spaces of the city, also this take advantage of the site where it's located. On its main public floor, an automated ventilation system takes advantage of the natural air current of Golden Gate Park to regulate temperatures inside the building. Minimize non-renewable energy consumption. The building itself is all conceived to be eco-friendly without taking away the comfort of the people inside. During the day and night, the louvers that are all around the building open and close automatically to provide fresh air and cooling the building to reduce the dependence on chemical coolants. The many circular skylights on the roof provide natural light, and also as the louvers open and close automatically to allow the hot air escape. The building is mostly covered with floor-to-ceiling German glass that reduces the level of heat absorption, minimizing the energy used for cooling, and also allows the visitors to see Golden Gate Park from almost any point inside the museum. These floor-to-ceiling windows are also on the back of the building and allows the staff to open and close them as needed and provide natural light. The 90% of the spaces in the Academy have access to outside views and daylight. Another important component of the museum is the radiant floor heating system that, with tubes embedded in the concrete floor, carry hot water so people move through and helps reduce the building's energy need by an estimated 10% annually. Finally, the living room is the heart of the Academy, or mostly the brain. This perceives the weather stations, the wind, rain, and changes in temperature to inform all the building's automated systems and skylight, keeping all the spaces in a comfortable temperature and light. The Academy uses 1/3 less energy than comparable structures and generates 5% of total energy demand. About the use of environmentally preferable products, the roof is covered by solar panels and biodegradable vegetation strips, creating an eco-friendly important element on the building. Also, the Academy itself has a lot of alternatives to avoid using chemicals that affect the environment. For example, they use low-emission and ozone-friendly substances for refrigeration, heating, ventilation, air conditioning, and fire suppression.
Preservation of water. In this marvelous design, the conservation of water is a very important issue. So at the moment of designing the museum, there were several strategies to consider. First of all, this design got a LEED, Leadership in Energy and Environmental Design, rating, which is an excellent rate for a green system design, and for that reason, the engineering team had to fulfill several requirements. For example, water-efficient landscaping. The green roof provides the capture of 100% of excess storm water, giving a saving of 50% through the use of captured or recycled side water. This prevents the runoff from carrying pollutants to the ecosystem. Water use reduction. There is a saving of 66.9% through water reuse. Flow-low lavatories, kitchens, sinks, and showers. All of this was possible because of the recycled water system that the museum has. The seawater from the aquarium is canalized from the Pacific Ocean, which minimizes the uses of mineral water for the aquarium system. The leftovers of nutrients are purified with the natural system, so the water can be recycled. This new museum design produces 50% less wastewater than the previous design. Improving the indoor environmental quality. Apart from the museum visitors, there are thousands of creatures and species inside the structure. Therefore, it's a priority to maintain a comfortable and a healthy environment inside the building, but with the most minimum impact to the natural world. The ventilation and cooling system are one of the top features of this sustainable structure, and it's because are high-tech inventions. For the ventilation are the louvers and an automatic ventilation system which make 34% of saving in the optimization of energy performances. In the use of natural ventilation, heat recovery, displacing ventilation, and so on, making an inviting and comfortable atmosphere inside the museum, and what is best, a friendly ecosystem. Optimize operational and maintenance practices. The main idea for the design of the academy was to build a structure as green as possible, but to achieve that goal there were some issues to think of. Arup's engineers need to research and specify a diverse suite of solutions and equipment for the many topics to solve. Taking advantage of the San Francisco's mild climate was one of the approaches of the engineering team to solve the ventilation and cooling system, as utilizing floor-to-ceiling glass walls and the louvers in all the floors made possible the sustainable design standards. One of the Arup's largest roles on the building was providing structural engineering services. This role developed complex solutions for the main structure, the living roof, piazza skylight, the aquarium civic tanks, and the rainforest and planetarium domes, while maintaining Renzo Piano's architectural vision for the building. The structural solutions involved a myriad of materials including steel, glass, concrete, and acrylic.